Okay, the book talks about the complete graph. Well, on A, they did it in the standard viewing window. Okay, the standard viewing window for the graphing calculator is from -10 to +10. We can click on this Move Graphics button and click and drag, and voila, now I can see my vertex, which is a minimum on this one. Okay, did everybody find the Move button?
Yeah.
Okay. What conclusions can you draw about the appearance of the graph in the window used? Okay, so on this one, I could say, hey, I had to move my graph to see the vertex. Okay, now let's go to B. Oh, B, all they're doing is the same graph. They're changing the viewing window. Okay, so this is 1A of the examples on page 532 in your book. This is what's printed on. Do you see how their screen looks different than our screen?
Yeah.
It's kind of pixely, and, you know, the size of a graphing calculator screen is about, what, 3 by 2? You know, and here, if you can use your Geogebra on your laptop, which is free, you get a much bigger screen. Okay. So what you're going to do, okay, what they did is they changed the viewing screen and said, hey, look how it changes. We can play with that real quick. If I go to graphics, they did -10 to 10 on the X. And -200. To 200 on the Y. Okay, so without changing my equation, what happened to the appearance of my graph? It majorly changed the appearance, right? Okay, my equation is still the same. So the point is, same graph, different window, it looks very different. Okay, I don't want to take the time and do 2 more of change the window ones because that's really not the point. Okay, so number 1, what you guys are going to do, I'm going to go back to that standard viewing window. Okay, Control Z works in Geogebra just like it works in the rest of the Windows world. Undo is great. Okay, so for number 1, we're going to type in, either you can delete the one you have, or we can just change it. I'm just going to change mine. -x squared is all I want, right? You can just delete it if you want to, or so like you could right click and then pick delete, or you can just double click on it and type in there and hit enter. And now I have the graph of y equals -x squared. So you're going to plot points on your graph paper and draw that parabola. Okay, yep, we're going to have 3 graphs on your graph paper on number 1. Now, to tell the graphs apart, I'm going to change my color. Pink. You don't have to change your color. I just am, so it's easier to tell them apart. Okay, so and then in the input part, I'm going to put the next one is y equals -3x squared. Purple. And then the last one was y equals -6x squared. Okay. So the directions are to graph each family of equations on the same screen. So you're going to draw those 3 parabolas on your graph paper. and then it says compare and contrast the graphs. Okay, so compare, that's what's the same. So what's the same for all three of these graphs? What? Okay, two people are talking. Okay, so the vertex is at the origin for all three. Sam, is that what you were saying too?
No, they both have a maximum.
Okay, they all three have a maximum. And there's one more characteristic I wanted to get that was the same. All three parabolas open downward. Okay, so that would be our comparison. Those characteristics are all the same. What's different? That's our contrast.
Wait, what's the con? They're all different.
What's different with these three parabolas? They all have a maximum at the origin. They all open down. Their vertex is all at the origin. What's different? As the coefficient of x gets bigger, they get smaller, or you could say narrower. I think that's a funny word. Narrower. It's a real word. I actually looked it up one time. Okay, so that's what you're going to do basically on all of these.